All right, dudes, what's up? We got chemistry class. I already started like 10 minutes ago. So I'm going to go over what we covered so far real quick. I forgot to press the record button. Thank you for reminding me. Look, here's the thing. We're talking about significant figures. Significant figures have these rules. These rules seem complicated. They're not really that bad. You just have to get used to them. First rule, non-zero integers are significant. So numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, those are significant. 0 could or could not be significant. It has its own set of rules, and it even has 3 categories as to which it falls in. Cool? Trailing or leading zeros. So if you have zeros, that's when you have to worry about whether or not this thing's significant or not. If they're leading zeros, that means if they're in front of the number that's important, they're not significant. They're never significant. Got it? If it's a captured zero, which basically means if it's a zero that occurs in between two numbers that are not zero. So it's for example, 1 and 7 are non-zero integers, and if it's these 3 integers and these 3 zeros in between, those are significant. They become significant because they're captured within. Got it? Trailing zeros, this is where it gets a little bit dicey. If there is a decimal place, then those trailing zeros are significant. If there's not a decimal place, those trailing zeros are not significant. Done. Got it? That's all we've covered so far. Examples. 0. Oh, wait. I've got one more case to cover. Sorry. Exact numbers. This is case number 3. Exact numbers have as many significant figures as needed. It has infinite significant figures. And just to give you a heads up, I'm lazy. I'm probably going to refer to these as sig figs. Exact numbers have infinite sig figs. For example, there are exactly 3 boys in this room, right? How many significant figures is that? Is it 3.0002 boys? No. There's 3 boys in this room. Well, how exact it is? Oh, I know. There's exactly 3 boys in this room. You know what I mean? So, I mean, it's almost like, how many significant figures does it have? Well, it has as many as you want. You could write 3.000000 and just keep going. There's exactly 3 boys in this room. Does that make sense? We cool with that? All right. Or like, how many eggs are in a dozen? 12. Are you sure? It's not like 12.4? It's not like 12.2789? No, it's 12. It's exactly 12. It's 12 with a perfect amount of zeros after it. You know what I mean? And the reason why I say as many as needed, you'll see when we start doing math, you'll see why I say as many as needed. But for now, you can just say it has as many zeros as you want it to have. After that, because it's exactly 12. There's exactly 12 eggs in a dozen. If you're talking about a baker's dozen, that would be 13. But I mean, that's something a little bit different. We cool? All right. So
that means there's 1 significant.
In a dozen, how many significant figures in a dozen?
12.
No.
1.
There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and forever and infinity. Exact numbers have infinite number of significant figures.
Oh, okay.
Exact numbers are exact numbers. If I told you 1 dozen equals 12, I don't mean it's about 12. I mean it's exactly 12. Got it? It's not like, oh, there's only 2 significant figures because you didn't measure, you don't know the uncertainty. It could be 12.5. It could be 11.79. No. If I'm talking about a dozen, it's a straight conversion. That is 12. That is defined as 12. You know, there are 3 boys in this room. There is not 2.87 boys in this room. There is not there's not 5 boys or 5.7 boys. I'm not unsure as to how many boys are in this room right now. There's no uncertainty. There's infinite amount of sig figs. Got it? Those are exact numbers. All right, anyway, let's talk about this. A student's extraction procedure of T yields 0.0105 grams of caffeine. How many sig figs do you see?
3.
I see 3, because those two those two leading zeros, not significant. This captured 0, significant. 1 and 5, non-zero integers, significant. Got it? All right, let's try this one. A chemist records the mass of, or a mass for analysis. The mass is 0.050080. How many sig figs? 5. Good. What if I put this? Oh, yeah. This would, someone's saying 5, someone's saying 7, and someone's saying 4. I'm assuming that the person who's saying 4 is only counting these 4. But even though this is a trailing 0, it still counts because there's a decimal in there. Now these two leading zeros don't count. So that's why there's 5. Got it? What if I did this?
Wait,
What
so
if I
it counts
changed?
if there's a decimal?
The trailing zeros count if there is a decimal.
So which one should count?
This trailing 0 right here is the one that was in question, the last one.
Uh-huh.
That one counts because I see a decimal in that number.
But the one outside of it, outside of the decimal, doesn't count.
Well, okay. These two, all right, here we go. Let's talk about this again. Okay. These two, 5 and 8, count automatically by Rule 1, right? Rule 1 says non-zero numbers count, Garens Bobarens. So I have 2 at least. Got it? Rule, I think it was 2B, says captive zeros count. So I can tell you that these ones count as well. Got it? Rule 2C, Part 2, says that trailing zeros only count if there's a decimal. So that one counts. Because that's a trailing 0, it counts because there's a decimal. Got it? Rule 2A says leading zeros don't count. So these don't count. Got it? So I see 5 significant figures. By the way, here I got a question for you. What if I change this to a 1? Now how many significant figures do you see? 7. Because this one becomes a captured 0. Got it? All right, cool. Let's see. How many sig figs here? 8.050 times 10 to the negative 3 seconds. How many sig figs? Did you say 7 in this number right here? This is 1.3C.
It's 4.
All right. What you would do is, yes, there are 4. You would only count these significant figures. This times 10 to the negative 3, that's a part of the scientific notation. I'll show you guys, I'll basically show you the rundown for this thing. If I wanted to write this in non-scientific notation, I would write something like this. 0.008050. Got it? All right. This is converting it to non-scientific notation. See these 3 zeros over here? Those aren't significant. The only significant part is the numbers over here. Got it? That's 1, 2, 3, 4 significant figures. The times negative 3, all that did was move this 0 to the left. But that doesn't change the amount of significant figures I have, right? Because that just added more leading zeros. Got it? All right. So when you write a number in scientific notation, the only part to look at that has significant figures is the number part. The exponent doesn't really tell you anything about the significant figures. Got it? All right. Keep in mind, by the way, some of you folks have been asking me about labs, and you are really excited about chemistry labs. And I'm going to say this. I'm really excited about chemistry labs. Although I don't know how viable it is that we have them. Because we don't have chemicals here. We don't have any chemicals that we can use here. I will try to MacGyver chemistry, you folks, as best as I can, and do chemistry with the stuff you can find at home and basically make stuff to blow it up and that kind of stuff. I will do my best to figure that out. how to do chemistry without any chemistry equipment. But I'll be honest with you, the reason why I'm doing such heavy book work is not because I'm a jerk, or and it's not also because I don't have the equipment. It's because this is the hard. I mean, the labs are fun to do, and when you go to college, you'll be able to do them. But the hardest part of chemistry that I want to teach you guys is the bookwork part. So that's why this chemistry, and I hate to say it, but college chemistry is going to be a lot of bookwork stuff. Celeste, can I ask you a question?
Yeah.
You took chemistry in college?
Yep.
How much of it is bookwork and how much of it is lab?
You don't get to lab unless you understand the book.
The book is super important. So it's not to say that I'm gonna like just drown you guys in bookwork. I will do my best to make chemistry fun, interesting, and we'll try to blow stuff up as best as I can. But we're gonna have to hit this stuff, especially this chemistry stuff right here. All right, can you go over question 10 on the homework? I don't get what I'm supposed to do. I'll tell you what. I'm gonna try my best to finish at 3:15, and if I finish by 3:15, I'll try my best to. Then what I'll do is I'll go over that question on the homework. I promise. Sound good? Can you remind me to go over that at the end? All right. So you guys get significant figures?
Yeah.
All right. Rules for significant figures in mathematical operations. All right. Here's what you do. And I need to go over this. If I told you something like, I measured my weight out to be, let's see, or I measured the weight of an apple to be exactly 4.56 ounces, or a weight of I don't know what the weight an ounce is. I mean, maybe that would be the weight of a ball or something. Okay, if I have 4.56 ounces, and I tell you, so I tell you, okay, the weight of this ball is 4.56 ounces. Got it? Okay. How many significant figures? 3. Got it. And I tell you, I have about 1.4 balls.
Well, that sucks.
Hee hee hee. I know. Ha ha ha. You're so funny. Okay. All right. Fine. I have 2.4.
That's a little excessive.
Yeah. Overcompensating a little bit, huh? All right. Fine. All right. So this number is not exact either.
You're a monster.
Yeah, I know. Hey, grow up. You're a junior now. All right. How many significant figures does this second number have? 2 significant figures. Now, if I want to say how many ounces do I have altogether, what would I do? I'd multiply them together, right?
Yeah.
All right. So, if I multiply 4.56 times 2.4, someone use a calculator. I'll try to do it in my head. It's 6.38. Is that right? Did you guys use a calculator? 6.38. So you would tell me, in the end, hey, you have exactly 6.38 ounces of stuff. Maybe I should say, anyway, whatever. Right? Do you guys all agree? Assuming I multiplied it right.
10.9. Yeah.
Is it 10.9? Oh, yeah, you're right. 10.9 ounces. 10.944? All right, fine, let's do that. 10.944 ounces. Got it?
Yeah.
All right. Here's the thing, folks. Your one measurement was accurate up to 3 significant figures. The other measurement was accurate up to 2 significant figures. So your answer should have how many significant figures?
3 or 5. Or
No.
4.
The answer is 11.
Duh. 11?
No, not 11 significant figures. The answer to this problem is 11 ounces.
Oh, okay, you round up.
Because I need to have two significant figures.
Gotcha.
How is it that by multiplying these two numbers, my weakest measurement is going to get more accurate to three significant figures? You know what I mean? Like how does that even come close to make sense? So what you do is if you're multiplying two numbers together, and one has three significant figures and one has two significant figures, what you do is you take the one that has the least amount of significant figures, and you round your answer off to only have that many significant figures, because that kind of limits your measurement. You know what I mean? Your answer is, I guess it's kind of like that saying, your team is only as good as its weakest player. Your answer is only as accurate as the least accurate measurement that you have. Does that make sense? All right. So there's a different rule for adding and subtracting. And okay, this rule also goes for division, by the way. This multiplication rule also goes for division, because division is just, the inverse of multiplying. All right. There's a rule for adding and subtracting. And that says this. All right.
Don't feed the monkeys.
The result has the same number of decimal places as the least precise measurement. So, for example, if I have 12.11 and I have 18.0, which one has the least amount in its decimals? The 18, exactly. Very good. So what I have to say is I'm going to still add this together, right? So you end up getting a 1 and a 1 and a 0 and a 1 and then a 3 and drop the decimal. But I have to cut this this answer off to only include this significant figure, right? Because when I add these two together, how is my answer going to be more accurate than the least amount that I started? It's a little bit different from adding or from multiplying, but I mean it's kind of the same concept. So my answer is 30.1. Got it? By the way, if this were something like 12.15 plus 18.0, then my answer will probably be 30.2. Do you guys understand why? Do you guys understand why it's 30.2 as opposed to 30.1?
Because can.
No, not because can. Because originally because if I add these together, it would have been 30.15. But I'm cutting this off after this significant figure, so the 5 rounds it up, so it becomes 30.2. That is the answer. This is why, after this point, this is why before all of your homework, I gave you a margin of error. I said, give me the answer, and I don't care if plus or minus 1. If you gave me a different decimals, I'll give you points for it. But at this point, from this point on, after this lesson, I have to say, no, I'm going to be a punk when it comes to significant figures. Because this stuff is important in chemistry. You don't want to accidentally measure too much, or you don't want to accidentally report that you did something more accurate than you actually did.
Right.
Does that make sense to you? As to why we would be sticklers about this? So what I'll probably do is I'll probably put in an answer where you have no margin of error. Okay, you have to give me 30.2. If you gave me 30.1, I know you did it wrong. Okay? So you got to be careful with this kind of stuff. All right, let's do this. What is 1.05 times 10 to the negative 3 divided by 6.135? All right, here's what I would do. I would do the 1.05 divided by 6.135. Use your calculators. Tell me what that is. You get your phone? Give me the numbers.
0.17114914.
And I still got to tack on the times 10 to the negative 3. Cool.
1 1 after the 7.
So, oh, there's 2 ones?
Yeah.
All right. Well, actually, how many significant figures should I have? I mean, you guys listed all the numbers that were on your calculator, but you guys, you know what I mean?
Yeah.
But it's a little ridiculous because we talked about uncertainty in measurement, and apparently this thing is not super accurate measurement, and this thing is not super duper accurate. So why are you listing like 10 significant figures for me? So what you need to do is
0.17.
0.17. Is that what you folks are saying? 0.17? No, it's 0.171 times 10 to the negative 3. Because this is the 3 significant figures. Got it? Does this make sense to you?
Yeah.
Sure? I know it's tough. All right.
Wait, what? I thought if there's a decimal, then 0 counts.
If there is a decimal, the 0 counts if it's a trailing 0. Leading zeros never count.
So if it's behind the decimal, it's leading 0.
Not if it's behind the decimal.
It's in
If
front
it's
of the decimal. It's
not if it's in front or behind the decimal. If it's after numbers, then it counts. If there's a decimal. So like.
So 0.171 does not count.
This is only 2 significant figures right here. What I have here, 0.17. That's why. I have a feeling that's why
I got it.
Alana said, "Hey, that's the answer." Well, no, that's not the answer. You need the extra 1 because that's 3 significant figures. You know what I mean?
Yeah.
All right, cool. Now, technically, I mean, this is correct, but I wouldn't write it like this. Mathematically, we always like writing it like this: 1.71 times 10 to the negative 4, I think it is. Yeah. This would be the better way to write it. And this goes back to scientific notation. When we write things in scientific notation, we always like to have only one number to the left of the decimal place. The rest of them have to come after. Got it?
So,
Questions?
wait. Oh, never mind.
Why would it be to the negative 4? All right, here's what I would say. I'm teaching my son to divide by 1,000 right now. He's 6th grade. So what I'm doing is I'm teaching him, when you divide by 1,000, you move the decimal place 3 times to the left. Okay? Let's take this number and move this decimal place 3 times to the left. It would be 1, 2, 3. So your answer would be 0.000171. I'm arguing with you that if you move this one 4 decimal places to the left, it would be the same as this number. If you don't believe me, check that.
Check on.
All right, I'll tell you what. Check it now because I want you folks to finish this off. All right. And Madison, yeah, go for it. Check it now and make sure that I'm not spewing craziness. I'm actually speaking correctly. So that negative 3 isn't an exponent. It is an exponent. The negative 3 is an exponent on the 10. So this is 10 to the negative 3. This is also known as 1 over 10 to the cubed. This is also known as 1 over 1,000. This is scientific notation. Why do you want 3 zeros in front of the number? Why do I want 3 zeros in front of the number? Okay. I have a feeling I might be going fast. Am I going too fast for you? All right. Why do I want 3 zeros in front of the number? Let's go back to that question. The answer was 0.171 times 10 to the negative 3. Got it? I tell my son that when you divide by 1,000, because right now I'm teaching him how to divide by 1,000. And when you divide by 100 and divide by 10, those are really nice because all you do is move the decimal place to the left by however many zeros you're dealing with here, right? And when you multiply by 10, 1,000, 100, those are nice too because all you do is take that decimal place and move it to the right, however many zeros you're dealing with there. Does that make sense to you? Right?
Yeah.
So in this case, we're dividing by 1,000, which means I move this decimal place 3 times to the left. So it's 1, 2, 3 decimal place. That means those 2 extra placeholders I need are zeros over there. That's what I'm doing. Got it? And what I'm saying here is that this answer moved 3 decimal places to the left is the same as this answer moved 4 decimal places to the left. And then you guys look at it and just be like, yeah, I agree with that. That makes total sense. We cool?
Yeah.
This answer is technically the one that is more correct, even though both of them say the same thing. Because significant figure rules say that, wait, I don't understand what the comment about no you don't. Were you confused about something? All right, anyway. The significant figure rules say that whenever you write significant figures, or the scientific notation rules say that whenever you write scientific notation, you write down you put a number in front of the decimal place, and only one number goes in front of the decimal place. Everything else goes behind the decimal place. So you don't ever put a 0 at that decimal place. That's it. All right, there we go. So let's try this one. 21 minus 13.8. Plug that into your calculator. What is that answer?
Let's say 13.
All right. Whoa, I got 6.2, 11.2. Which one is it? I think it's 7.2.
Yeah, 7.2.
7.2.
Do that in the head.
Awesome. Good. 7.2. Is that your answer? Is that the answer you're going to plug into the computer? Well, this one has 2 sig figs. This one has 3 sig figs. So I'm going to choose my answer to limit it down to 2 sig figs, right? Wrong. Remember, the adding rules are different from the multiplying rules.
1.
21 has no sig figs after the decimal. 13.8 has 1 significant figure after the decimal. So you only limit it down to just 7.
Why?
Because you cut off all of these, even though the answer is 7.2, you cut this off. Because this one didn't have a spot there.
Your friend Juan.
What about 1? What?
Juan.
So yes, 1 significant figure. My good friend Juan.
Yeah.
All right. We cool with that? Does this make sense to you?
Yeah.
You sure?
Roger.
It's tough, but so confused about the cutting. Okay, I'm gonna go back to that thing where I said when adding and subtracting. If you read the text, it's in there.
That guy.
All right. Well, okay, fine. Since some of you are confused about the cutting, let me go back and read to you the rule about adding and subtracting. Adding and subtraction, the result has the same number of decimal places as the least precise measurement used in the calculation. So, 21 has 20, or I have the number 21, I have the number 13.8. I'm going to subtract that. 7.2. That's what a calculator would tell me. But then I say, well, which is the least precise measurement in these two numbers? The 21 or the 13.8? The 21. How many decimal places does the 21 have?
Blackjack. None. It's infinite.
None. No, it's not infinite. It just has none.
But none. No.
Right.
No
0. It has none. So how many decimal places should my answer have?
None.
So I'm going to cut it.
Adios.
Done.
Juan.
Does that make sense?
Yeah.
All right. I'll be honest with you. This is tough stuff. And the reason why I'm going through this stuff with you is because this is the way we do it. We need to standardize this as a convention. You know what I mean?
Yeah.
And you know what? I'll tell you what, Bradley. This is weird, but But the college professors do the exact same thing. So it's you either pay now or pay later. It's gonna be weird for you now, or it's gonna be weird for you later. I'd rather it be weird for you now. I'd rather this be hurt your brain now when you have Mr. Daldy to kind of baby you.
This is easy.
And believe it or not, Mr. Daldy doesn't baby you very much, but Tejas knows that. Of course, Tejas is used to being surrounded by people who don't baby him.
Mr. Tate. Oh my God.
Mr. Tate was fun. All right,
Mr.
anyway.
Tate.
All right. Chase up.
Oh.
I'm kind of glad you're
Let's
here
do this
for
one. Let's do this one.
Once.
I'm gonna go. I have a pencil that is exactly 7.000 inches long. My pencil is 7.000 inches long, which means I got out a super accurate a super accurate ruler and measured it. Got it? Probably use a laser or something like that to get it down to like, what is that? 1/1000 to get it down to 1,000th of an inch. And I knew it. All right. Okay. Good.
My laser.
How many centimeters is that? Now this is something you've done before, and I'm going to show you my systematic way of doing it, and it's very important. Got it?
How many
All right.
centimeters is 7 inches?
How many centimeters is in 1 inch? This is the first thing you write down. So, how many
Bye, guys.
centimeters? That's the question I'm asking. All right, so here's what you do. You say 1 centimeter equals, actually, no. The conversion that I know is 1 inch equals 2.54 centimeters. Got it? So 1 inch equals 2.54 centimeters. Where did I get that? I memorized it. Where did I get that before I memorized it? I looked it up in a table. Got it? If I ever give you a problem like that, I will probably give that information to you. Except converting an inch to a centimeter, you folks should memorize that. Cool?
2.5 centimeters.
2.54 centimeters.
2.54.
Okay? And
Sorry,
by the way,
boss.
keep in mind, how many significant figures is 2.54? 3. You say 3? Everyone says 3? Well, I hate to say it to you, but you guys are wrong. In this very specific case, in this very specific case, 1 inch is defined as exactly 2.54 centimeters. This thing has infinite significant figures.
Stuff.
It is you know what I mean? This is one of the weirdest ones. But this particular case, it has infinite amount of significant figures. All right. Anyway, that's actually I did want to talk about that a little bit, and the book forgot to tell you about this information, but that's one of these special cases. Anyway, here's what you do: is if I were to go 1 inch divided by 2.54 centimeters, like this problem shouldn't be that hard for you to do, but I'm going to do it in a very systematic way because these unit conversions can get very confusing. Okay. 1 inch is divided by 2.54 centimeters. What does that equal to? Well, if I told you 1 inch is the same as 2.54 centimeters, then no. I don't even know how to pronounce your name. Kaelaka? Is there anything you call you for short?
God, Mr. Daldy. Come on.
Kai? Is that it?
Kai.
Kai. All right, fine. Kai is absolutely correct. It's 1. If you have 1 inch divided by 2.54, I told you those were equal. If you have something divided by what is equal to, the answer is 1, right? Right? All right. Also, what happens if I have this? 2.54 centimeters divided by 1 inch. What does that equal to? He's a good friend of mine from California, Mexican guy. His name is Juan. Exactly, it's 1.
It's 1.
It is also 1.
It's 1 again.
It is just a different kind of 1.
Yeah, you.
Mathematically, they're both equal to 1.
Mathematically.
So, check this out. When converting units from one unit to another, what you want to do is you want to do this. You want to write down the thing, 7.00 inches. And by the way, this is in the numerator. And I usually, when I convert units, I make a table like this. Okay?
Hi.
And what I want to do is I don't want to change the quantity of this thing. I'm not multiplying by the number 2 or something. I'm just changing the close on this thing. I'm giving it different units. So I want to multiply by the number 1. But here's the question. Do I use this one or this one? The first or the second? Sophia's saying the second. Okay, I agree. 1 inch, 2.54 centimeters. And the question is why?
Why, Juan?
How come? The reason being is this. Because in the end, you want your answer to be in centimeters. So see this inches over here? It gets killed by that inches down there. If you had that flipped over, that wouldn't have worked.
The flip side.
Does that make sense? So your units in the end is centimeters, and what you would need to do is multiply 7 times 2.54 centimeters. So what is 7 times 2.54? Anyone know? 17.80 centimeters. But here's my question: do I have to? Is my answer 17.8 or is my answer 17.80? Which one would you folks write down? Oh, oops. Actually, wait. What is it's 17.78? I'm sorry.
Yeah.
I screwed that up. All right.
17.
17.78 centimeters. Sorry, I didn't use a calculator. I just tried using my head. All right, so my question is, would I write down 17.78 or would I write 17.8 centimeters? Which one is correct? The top or the bottom?
The bottom.
All right, Madison says the bottom. Everyone's saying the bottom. Bradley's saying the top. All right, Bradley, fight. Why? What's going on? Why are you saying the top? Oh, Sophia jumped on his side now. What do you guys say? Bottom or top?
I prefer the bottom, but I like the top.
What? Choose one, bottom or top. You guys are crazy. All right. Anyway, the answer is this. It's the one on top.
Ooh.
The reason being is this. It's because, yes, I agree with what you folks were saying where the answer should have 3 significant figures because in all of the numbers I used, this has 4 and this has 3 significant figures, right? And so you said, hey, the answer should have 3 significant figures in the end because 2.54 has only 3 significant figures. But Sophia is correct. In this specific case, 2.54 has infinite amount of significant figures. Got it?
Yes.
All right, here. If you're confused, why don't we do this? Why don't we talk about this? If you're confused about this, then I'll make up an example off the top of my head. I have 30 eggs. How many dozens is that? How many eggs in a dozen?
12.
So the one, quote unquote one that I'm going to use is 1 dozen is equal to 12 eggs. Right? So here's what I got. If I have 30 eggs, and let's make it 30 point eggs. So at least I have 2 significant. Let's make it. I have 30.0 eggs. So I have 3 significant figures in my thing. I counted my eggs. I know I have exactly 30.0. I don't have 30.01. But I have 30.0. Let's just pretend. Got it? And I divide, and I say how many dozens do I have? So I say, okay, well, I'll make that little table thing, and I'll say 12 eggs in the bottom, 1 dozen up on top, and what I'll do is I'll say, okay, well, eggs cancels out with eggs, and so I have 30 divided by 12, which is 2.5. Is that what you guys got? 2.5? $2.5 dozen. Does everyone agree with that answer?
Yazoo.
Why? Because I disagree. It's 2.50. Because even though the number 12 only has two significant figures, it is defined as 1 dozen is it's equal to exactly 12. Right?
Infinite.
So it has infinite significant figures. It has as many significant figures as I need it to have. So my original number had 3 significant figures, so my answer should have 3 significant figures. Because that 12 doesn't mess with things. Does that make sense to you?
Yeah.
Because the 12 is an exact conversion. Do you folks see how these rules about significant figures is going to play such a big role in chemistry? And I hate to be the bearer of bad news, but this is just kind of how it is. This might blow your mind, but this is the way things go. All right, I will do my best to soften this blow and take you through this step by step. Got it?
Yeah.
All right. It's like proofs in geometry. No, it's not really like proofs in geometry. It's just more like being careful. But then again, a lot of you folks come to me and say, I want to be an engineer. And if you're an engineer, I hope that you learn how to be careful. Because if you don't be careful, you're going to build a bridge that will fall down. Be like, oh, I used centimeters and it was supposed to be inches.
After this class today, I don't want to be an engineer.
Yeah. Okay, fine. If I turn you off from being an engineer after one class, then maybe you should have been an engineer to begin with, because this is like not easy stuff, but this is the foundation of this stuff. You know what I mean?
I'll get it once I learn better.
I'll be honest with you. Look, here's the thing. This is hard now. Don't freak out. I've been doing this for 20 years.
Freaking out.
When you've been doing this for 20 years, you'll get good at it too. Sound fair?
Yeah, I want to be a doctor, so I'll be doing it for many more than 20.
Well, yeah. But you'll be good at it by the time you have 20 years of experience doing this stuff.
Yeah.
Cool. All right, here we go. Unit conversion 2. You order a bicycle with a 25.5-inch frame, but the sizes in the catalogs are given only in centimeters.
Geometry.
Which one should you order? You know what? I'm going to skip that one. That one's boring. All right, let's do this one. You have 10K run. And let's make it 10.0 run. You want to be an anesthesiologist? Well, Mr. Bradley, first of all, my wife loves anesthesiologists, particularly when she was giving birth, and she was like, "Oh, you are like God's blessing to mankind." Right? So
Who says that?
well, my wife does.
Oh.
Anyway, because she's really excited, because she's in a lot of pain when she's giving birth, so she's like, "Oh, I love the anesthesiologist because he takes away my pain."
Oh.
Anyway, but Mr. Bradley, if you want to be an anesthesiologist, here's what I would say. You had better darn well learn these significant figures, because if you're off by a little bit, oh, I just need to give them about 11 cc's of this thing, then you'll be like, yeah, no,
11.1. Oops.
yeah, that's gonna kill them. You know what I mean? So if you say 11, you better mean 11, as opposed to saying, like, if you say 11.5 or 11.0, it can't be 11 give or take 5.
It's your job to put my heart guy under.
Right. So I'm just saying. All right. Anyway, let's go through this one. You run a 10K run. How many miles is that?
That's low.
All right. Let's do it. Here's what I would do. To be honest with you, I don't know every single unit conversion in my head.
You should.
And here's what I'm going to say. You could use Google. You could just Google this and be done with that.
Google it.
In fact, your homework would probably be very quick. However, I'm going to tell you now, you are burning yourself if you just rely on Google. Because on a test, in a face-to-face college class, you will not have Google.
Right. I think it's 6.
So what I'm saying is, practice it now while Mr. Dalday is kind of still nice to you guys.
6.2.
Got it? All right, here's how you do it. You ready? The only conversion that I know is 1 inch equals 2.54 centimeters.
Yeah.
That's the only complicated. Oh, and I think 1 mile is 5,260 feet. Can someone look that up for me? Is it 5,280?
How many feet in a mile?
Yeah, just look it up. That's Siri.
5,280.
All right, so 5,280. I apologize. Okay.
I'm sorry, I still use Siri.
No, it's all right. I'm fine with you using Siri. Okay, so check this out. If you want to run a 10K
I
run,
swear.
okay, I'm going to multiply this by a series of ones, and I'll show you how I do this. 10K kilometers, I can convert kilometers into meters. I just say 1 kilometer is 1,000 meters. Does everyone understand how I did that first step?
Yeah.
You don't understand that?
Kilo is 1,000.
1,000 meters is the same as 1 kilometer. Agreed?
Oh, okay, I didn't hear you this time.
All right. Okay, everyone understands how I did this first step because that's important.
It's 1 meter.
Okay, now I'm going to say something like 1 meter is 100 centimeters.
Hoorah. 2.54 centimeters.
This homework is technically due tonight. Do you want me to make it due tomorrow? Actually, did I tell you it was going to be due tomorrow?
No.
Yeah, I did. I said I
Oh,
would
yeah,
push
you
it
did.
back one day
That's right.
and I would give you
Sorry.
6 attempts. Fine, it's due tomorrow. But do you understand where I'm going? No, actually, you know what? This homework on the significant figures homework is due on tomorrow. This homework is also due tomorrow, I think, because it was already due tomorrow to begin with.
999.
I think that's the way it goes. Anyway, I'll tell you what. If you want, I can push that one back a day too. I don't mind. Actually, you know, I'm going to keep it because if I keep pushing this stuff back a day, it's going to kill you guys. All right. Then what I'll say is there's 2.54 centimeters in 1 inch. And then what I'll say is there is 12 inches in 1 foot. And then what I'll say is there's 5,280 feet in 1 mile. And here's my favorite part, canceling them out. This kilometers on top gets killed by that kilometers on bottom. That's why I put that kilometers on the bottom. This meters on top got killed by that one. This centimeters got killed by this centimeters. This inches got killed by that inches. This foot got killed by that foot. And I converted it to my units that I want, which is miles. So now, on your calculators, type in 10 times 1,000 times 100 divided by 2.54 divided by 12 divided by 5280. Again, in your calculator, you type in 10
5.280 or 5280?
5280. 10 times 1,000 times 100
Ah!
divided by 2.54
What do you think it is, Mr. Dalday?
divided by 12 divided by 5280. I'm going to do it in my head, and I would say 6.22.
Oh, so close.
What is it?
6.21.
6.21. Give me all the numbers.
213711191.
Okay.
292.
6.213.
71192.
Right. But we limit it down to, see all of these conversions, you don't
1-1.
care about any of these significant figures. Because there is exactly 100 centimeters in 1 meter. And there's exactly 1,000 meters in 1 kilometer. That's how it's defined. Apparently there's exactly 2.54 centimeters in 1 inch. There's exactly 12 inches in a foot. You know what I mean? There's not 12.2 inches, or I'm unsure about how many inches are in a foot. There's exactly 12 inches in a foot. A foot is defined as 12 inches. So all those significant figures, all don't care. The answer is 10.0. Or the answer has the original one has 3 significant figures. I cut this off to 3 sig figs, so it's 6.21 miles. The homework put if you the homework told or if you put in 6.21 and then the homework puts in 6.210000, does that make it wrong? Technically, yes. That gives it a whole bunch of significant figures that shouldn't be there. But I think that's the way goes. That's the way love goes. No, that's the way the computer grades it. I don't know why. Cool. I'll make a deal with you. It's probably be a good idea if I cover at least one more before I go over the homework with you. Would that be all right with you? All right. Let's do this. The speed limit on the freeways today are what? Are in Hawaii are what?
25 miles per hour is like a general one.
No, a speed limit on the freeway.
On the freeway.
Yeah.
60.
55.
60.
No, that's how fast you drive, but I'm telling you the speed limit is 55. Good. Awesome. All right. Let's say you're from England and you go you don't go in
Someone said 5.
let's say you're from England and you're weird. So you want to measure this in meters per second.
55 meters per second.
Convert that. 55 miles per hour is the same as how many meters per second? Okay? Let's do it. 55 miles per hour. I'm going to make that little table. Okay? Let's convert miles to meters. So I know that there are 1 mile for every 5,280 feet. I know that 1 foot is 12 inches. I know that 1 inch is 2.54 centimeters. I know that 1 centimeter, actually no, not 1 centimeter, it's 100 centimeters is the same as 1 meter. Agreed? So in the end, what are my units? Miles cancel with miles, feet cancel with feet, inches cancel with inches, centimeters cancel with centimeters. My answer is there's a meters in the numerator. Am I done?
Are you?
No, because I asked the question that I asked is I wanted seconds in the denominator. And in this answer, I have hours in the denominator. So I need to convert that hours into seconds. All right, fine.
Seconds in an hour.
1 hour is 60 minutes.
60 seconds.
1 minute is 60 seconds.
Shorty.
So this hours on the bottom will cancel out with that hours on top, minutes with minutes. And then my answer is going to have the units of meters per second. I'm glad about that. So then what you do is you plug that into your calculator and you say 55 times 5280 times 12 times 2.54 divided by 100 divided by 60 divided by 60, and you plug that into your calculator and tell me what the answer is. This is like a second math class, and my answer is yes. And I'll tell you what, this is like a second math class, but it's still way easier than
Still
physics.
beats geometry. Oh, yes, it does.
I'm letting you know,
Doesn't make any sense.
this is way easier than physics.
Yeah, you.
Physics is like this kind of math just on steroids.
No, you don't understand. It beats the geometry class we have right now.
All right, fine. I'm not going to speak ill about that geometry teacher. I like it a
No, the
lot.
geometry teacher's great. The
Yeah.
class is
Well, what's so hard about it?
It
No,
it
it's
just
not
doesn't.
hard.
It doesn't. It doesn't.
Suddenly, I don't want to take physics. Okay, all right, fine. No. I'm the physics teacher. I'm the physics major. Actually, I'm not a chemistry major. I major in physics. Anyway, whatever. Bradley's like, I have ouch too, and then Bradley's like, but then I have Mr. Dalday for 2 hours, or for like, he had me for 2 hours before this. We started at 12:45. I have not stopped talking since 12:45. That's why I was coughing in my throat. Anyway, somebody said the answer is 24.58. All right, fine, 24.5872. But I would report my answer as just 25 meters per second. In fact, technically speaking, I probably would do something like 2.5 times 10 to the 1 power meters per second. That is technically the best answer. Because it's in scientific notation, it has one digit in front of the decimal point, and yeah. But really, it's just 25. And the reason why it's 25 is because I had to round it down to two significant figures, because I started with two significant figures. And all of those unit conversions were exact numbers. So I don't have to limit any of my significant figures based off of those things. And for the most part, I think unit conversions are exact number conversions. Got it?
Got it.
Good. All right. I'll tell you what I'll do. At this point, I'm done with lecture. My voice hurts. I'm good. But Mr. Daldy will go free reign and do 3 problems from your homework just for you. I won't even I'll do 3 problems and I'll tell you the answer. And if I wrote the problem down wrong, or if I did something wrong, I'll fix that mistake too. I hope you feel like please know that Mr. Dalday, I don't mind fixing mistakes. I make a lot of them. Okay. Question number 10. Now you're talking about question number 10 for the significant figures one, right? Okay, all right. Can I go over one of each type of question? No, I'll tell you what. You choose the question. I'll go over it. All right. Question 10. And you're talking about the significant figures homework, right? All right, good. All right. So if I want to do question 10, I really got to go back to question 9, which says, let's see. All right. It's what I need to do is I say, all right, 0.000341559. That looks like pi to me. Anyway, you want to round it down to 3 significant digits. Okay, fine. This is 3 point. Actually, if I round it down to 3 significant figures, I write it like this: 0.000342. Right? Agreed? Done? Check? Understood? All right. By the way, there. Okay. If I wanted to, I know that it doesn't let you type that much. Here's what I'm trying to do, and maybe I should have recorded a video on this, so I don't mind doing this problem at all, because it was a little weird as to how I asked it. If I wanted to write that in scientific notation, I would write that as this: 3.42 times 10 to the negative 1, 2, 3, 4 times 10 to the negative 4. Got it? So in question 9, the answer is, what I wanted you to put is 3.42. For question 10, the answer that I wanted you to put is negative 4.
We're done with class.
Done. I gave you the answers, 9 and 10, right now.
Okay. For today's homework or for yesterday's?
For today's homework.
Oh.
The answer I wanted you to put in for question 9 is just the number, and the answer I wanted you to put in for question 10 is give me the exponent that's supposed to be there in the scientific notation part. Because I didn't know how to ask. I didn't know how to tell the computer to ask for the scientific notation.
So one's the decimal, one's the scientific.
One's the number, the coefficient, and one is the exponent in the scientific notation.
And one's just the whole thing.
No.
8, 9, and 10.
This is the answer. Here's what you would type in for question 9, and question 10 is that. It's basically, I didn't know how to have you type in this thing right here, so I just asked it in 2 separate parts. I just said, okay, give me the number part of the scientific notation, and give me the exponent part of the scientific notation. Done. Let me go back. I think that's, actually, I'm pretty sure that those are the numbers I typed in, so that's why it would be confusing. Okay. I don't know about question 8.
Back.
Did you want me to do another one, like 32, you said? Yeah, you can leave if you want.
I just
I'll.
need to warm up my food. I'm starving.
I haven't eaten all day.
You don't have a metabolism like me.
Yeah, you're right. So what you're saying is my body should just eat the fat that it's gained, huh?
Yeah, mine's just like muscle. I eat muscle. My body will eat myself if I don't eat.
Question 4, is that a G or an 8? Oh, I see. Okay. Let me go back to question 4 and take a look. That's got to be an 8. There's no there would be no sense in having it be a G.
The tandoori chicken.
And by the way, number 20, question 4 is 1.
Yeah.
I think it only has one sig thing. Remember the scientific notation, the times 10 to the 8th power, that doesn't change the number of significant figures something has. All right. Someone wanted me to cover question 32. Is that what you wanted? I told you I would do 3 problems. I'll tell you what, Bradley, or Madison. I'll tell you what, Bradley. Let me check to see what I told the computer to tell you what question 9 was, or 10 was. I don't know what I told the computer. This was what? Question, it was number, which one was it? Oh, it was number 31, part A. I told the computer that the correct answer is, oh, shoot. I told it was 1, but it's supposed to be -4. I apologize. It should be -4. Oh, wait. No, never mind. Hold on. No, wait. Okay, this is number 31, part A. Okay, I told the computer the answer was -4. Yeah. Okay. No, I put it, yeah, -4 was the answer. No, it's not supposed to be 4, it's supposed to be -4. Yes, because when you have -4, it means you move this decimal place 4 times to the left. 1, 2, 3, 4, which will give you this number. Bradley and Madison, it seems like you guys can go argue about that if you want.
Go scrap.
Go scrap. No, hey, I joke about that, but I don't really joke. It's which not to say I mean fight, but what I mean is like the best way for me to learn physics and the best way for me to learn chemistry is to sit down and argue it with people. That's what I do.
Like scrap.
I'll sit down and I'll go to a blackboard, and I'll just like start writing things down. Just be like, this is how it is. And I'll tell you what, if I got it wrong and I made myself look like an idiot, which I do all the time, then I would say, then I can guarantee you that I'll never forget that lesson. But if I get it right and I make myself look like I just be like, that's the way I do it, man. That's the way I roll, like a boss, right? Then I'll also never forget that lesson. So me being argumentative and me like talking about how to do things and like arguing with people about how to do things, that's the way I learn. So when I say go beef it out, go talk about it, do it. Because Bradley realized that he was wrong. And now Bradley won't make that mistake again. And Madison realized that she was right. Now Madison won't make that mistake again. All right. Did you want me to do another homework problem for you or what? Yes, Bradley, you can turn on your mic. I will check the number for number 32. Number 32 is problem number what? What does it say in blue? I don't get problem numbers on this side. Okay, don't lose that ball. It's part of my 2-ball set. I'll show you. I'll be right back. Hold on.
You're the one who laughed at that, Mr. Dalton.
This is church, so that's not here.
It's weird. It stops when it.
What?
That's not. It's to show the coefficient of restitution in a physics problem. All right, here, wait. What were you saying? Yes, Bradley, you can turn on your mic. Go for it. I just need to walk around. I need to give my head a break a little bit. Oh, did I not turn up my volume? Maybe. Bradley, you talk to me. Can't hear you.
Can you hear me?
Yes, I can hear you.
Okay, so you know how like on the homework it says like you have to do the standard notation of the exponent, like the scientific notation.
Yes, I want the I would like the number and the exponent in the scientific notation.
Now, when you do the scientific notation, do you use it to where it's like the original, like you do it so that it equals the first number or the number that they say they want it to, like just go to question 11.
Okay, question 11. I'll go there. All right, I'm at question 11 here. Yes, I'm looking at it now.
Okay, so you know how it says like 103.351 times 10 to the second?
Okay, 1 second. 103.351 times 10 squared. Got it.
Yeah. So like,
All right, here's what I would
do
do.
they want
Here's what I would do.
for the X? Oh, okay.
And I'll be honest with you. I made all of this homework. I mean, I made up this idea behind this scientific notation and stuff like that. So I could have put in the numbers on accident wrong. But here's what I would do. First, they want to round it up to 4 sig figs. So I would say, all right, that's 103.4 times 10 squared. Cool?
Wait, what? They wanted up to 4 digits.
Because the problem said round it to 4 digits.
Yeah.
Oh, I don't know special. Oh, yeah, round off. Okay, never mind.
Yeah, round it to 4 sig figs. So I did that first. And then when expressing this in scientific notation, I'm going to do it right off the bat, and it's going to confuse you, and then I'll show you how I did it slow. I would write that as 1.034 times 10 to the 4th power. So when I plug in my answer, I would say the answer is 1.034 for the number and 4 for the exponent.
Okay, now when you do the notation, what are you trying to get it to? Like, are you trying to get it back to the original like form, like 103 point?
No. Scientific notation, and I kind of, you know what? I realized that I kind of skipped over this. And so maybe this is what's kind of confusing you is when you write scientific notation, you always write it so that you have 1 digit in front of the decimal and only 1 digit. In
Well, I
fact,
got that. So, okay, so it is -4.
no, it's not -4, it's +4. Here, I'll show you how I got from here to here.
Why is it? Okay.
103.4 times 10 squared is the same as 10340, right?
Yeah.
And I guess I could put a decimal place there just so I won't confuse you. Would you now agree that I wrote out the correct one? In other words, 1034 times 10 to the 4th Because to get from this number to this number, I would have to move that decimal place 4 times to the right.
Oh, okay. I
So-
kind of see what you mean.
So this is kind
I
of
get
the
it.
middle step that I took in my head. And that's why I told you I'm going to write down the answer. It might confuse you, and I'll show you the slow way of doing it. The middle step I took in my head is I said 103.4 times 10 squared is the same as 10340. Point. And then I said, okay, well, that's the same as 1.034 times 10 to the 4th power, because to get from here to here, you would need to move this decimal place 1, 2, 3, 4 times. Does that make sense?
Okay,
So this answer is mathematically equivalent to this answer.
yeah.
And I'll be honest with you, that is going to take practice. That's not a skill that's easy to just like
That's
do off the
it's
top of your head.
confusing.
It's not confusing if you write out each step. It's just students are not used to writing out each step, and so then they try to do everything in their head. And yes, if you do everything in your head, Garens will Barons confused.
Mm-hmm.
We good?
I'll probably get a lot of the homework wrong because I don't really get all of this, but
All right.
all right.
I'll tell you what. I'll do number 3. I'll do one more, and then I gotta go. You gotta go. I told you I wouldn't lecture till 3:40, but look, it's 3:37. Which one do you guys want? Someone's Kai's been asking for 31, 32 or something like that. All right, let's do 32. And then Kai, which one is it that you wanted? You know what? I'll take your email and I'll try to answer it. But I would prefer to answer it in class because then everyone gets to see it. And I guarantee you that you're not the only question that makes 3 or this up. But I think Kai was asking about 32. And there might be a mistake in the computer. And my answer to that is absolutely. There is absolutely a chance that I made a mistake. Because it wasn't the computer that made the mistake. I was the guy who programmed that computer. So I made the mistake. All right, anyway, let's do this one. Part A, how many inches? So congratulations. You and your spouse are proud parents of a baby born while you were studying in the country that uses the metric system. The nurse informs you that your baby weighs 3.91 kilograms and measures 51.4 centimeters. 51.4 centimeters. Convert your baby's weight to pounds and ounces and her length to inches. Oh, okay, wait. I'm looking for just the inches part. Okay, yeah, I'm looking for inches. So 51.4 centimeters to inches. So I can tell you 51.4 centimeters. I'll make that little table looking thing. I'm going to put the centimeters on the bottom. I'll put inches on top. Can someone do this on their calculator? What's 51.4 divided by 2.54? 20.23. Now, I think that what I would have done is round it off and make my answer 20.2. Let me see what I told the computer to tell you what the right answer is. Okay. It's hard because I don't have numbers exact. I don't get problem numbers. So I gotta find the thing. All right, here we go. All right, I told the computer to put the number. Let me see. 41. In this book. I told the computer to tell you it was 10. I must have put the answer in wrong. The answer is 20. 20.3. Now I got a question. Is it 20.23 or is it 20.25? 51.4 divided by 2.54, what is that? Oh, okay, it's 2.5. All right, so I would tell you that the answer is 20.3. Let's give you a little margin error, though. All right. So the reason why you were getting that problem wrong is because I put in the wrong answer. I said it was 10.25, and that was a typo. My finger probably pressed the 1 instead of the 2. My bad. Bradley, you keep on saying 20.23, and I am disagreeing with what you're saying. It's got to be 20.3 instead of 20.2. Yes. Yes, I agree. It's 20.3 instead of 20.2 or 20.25, and that should make more sense to you because of our lesson on significant figures. The reason why it's 3 significant figures is because you started off with 51.4, which is only 3 significant figures. The reason why you rounded up is because, because the one below it was a 5, so you round the 2 up to a 3. Done. All right, 300 point. How many significant figures? I'd say 3. Did I put that wrong in the computer? Okay. Let me use that as a quick teaching opportunity, and then I'm done. Look, I rarely ever write 300 points. That doesn't make any sense. And this is where scientific notation actually comes into play. The best way to write that is to write 3.00 times 10 squared. In this case, there is no question as to how many significant figures over here. In this case, you could have accidentally put a dot on the page. Let me take a look at number 8 and see what I did wrong there. All right. Anyway, that's a lot to cover. We covered 2 hours of chemistry. I personally do not want to do this every time, but I think that this is good stuff. I really, you know what, I hate to say that I apologize for doing a 2-hour lecture. I know that that's a lot of stuff. I know. But I think that this is the way it's got to be. All right? All right. You guys hang in there. This is good stuff. Okay, talk to you later. My voice hurts. Goodbye.